Hello everyone, welcome. Today we are going to see add two numbers problem from Leetcode. You are given two non-empty linked lists representing two non-negative numbers. They are giving the number as a linked list. The digits are sorted in reverse order and each of the nodes contains single digit. Add two numbers and return the sum of the sum as a linked list. You may assume the two numbers do not contain any leading zeros except number 0 itself. It is something good, so we don't need to worry about any leading zeros. We'll come to this point in a moment. They will give us two linked list, something like 2 2 4 2 3. If this linked list actually represents a number 342. This is a reverse order of a number in a linked list. And similarly 5 2 6 2 4 is actually the representation of 465. What we actually should do is 2 4 3, that is like 342, and 5 6 4, which is nothing but 465. Add these two, we will get 807, and then we should return that same as a linked list. So this also should go as 72028. We should create a linked list in the reverse order of the sum of the number and then return that back. As they have already mentioned here, there is not going to be any leading zeros. It means you will not have any more zero node to the right of the last number. So these are other two examples they have given, and here are the constraints. The number of nodes in each linked list is in the range of 1 to 100. So we may have up to 100 digit number, and each node value will be 0 to 9. Yes, we know that they are going to keep only one digit in that node, so it is going to be between 0 to 9. It is guaranteed that the list represents a number and does not have any leading zeros. Okay, so we can always assume the given list is a valid number in a reverse order. Let's implement this program. We have given two inputs, L1 and L2. So what I will always tell you is, instead of thinking about the smaller problems, let's try to break down the bigger problem and solve it in the bigger level. Later you can implement the smaller problems one by one. What I mean by that is, let's assume we have helper functions and simply call them in the main function, and later we'll go and implement the helper functions. So let's assume that we have some function which can able to convert the given list into a number. We will use the same helper function to convert the other number also. Now let's add them together to get the final answer. And we cannot return the answer directly. We have to actually convert that into a list and return it back. So let's assume we have helper function for that also and return from that. Let's implement these helper functions one by one. So as they have already mentioned, the list is going to be in the reversed order. It means we are going to get the 1th digit, 10th digit, 100th digit, and then the higher order digits are going to come in the later point of time in the list. So we have to take every element in the list one at a time and then multiply that with its position, then add to the final number. So let's take the given example 2 4 3, the list. And let's keep num as 0 initially. So we are going to traverse the list. We will start from 2 and multiply 2 with its position. It is 1's position, so multiply 2 with 1 and add that with num. So num becomes 2 now. Now go to the next element 4. Multiply 4 with its position 10 and then add that with num. Now num becomes 42. Then go to the third element, which is nothing but 3. multiply with its position, which is 100. 3 is 100th position. Multiply 3 with 100 and add that with num. So num becomes 342. If a list like this is given, the answer should be like. So one thing you should note here is when you are traversing the list, you should know the position also. So for 2 we were keeping 1 as the position, for 4 10 is the position, and for 300 is the position, and this number we have to maintain in the code. So let's initialize num equal to 0, and position also we will initialize to 1. Initially it is going to be 1. We will traverse the list until we reach the end. So we know that end is none. So we can traverse until list becomes none. And for every position we are going to take the value, multiply that with position, and then add that with the num. After doing this, we have to move to the next element. We have to update the position also. Now the num will have the value. Let's print it before returning it. So let's check whether the implementation is correct by commenting out these two lines. So we got 342 and 465 for the example 1, and example 1 we need to get 342 and 465. This function implementation is correct. We can go ahead to the next function. Next function we have to convert the number into a list. So we know that we have to reverse and create a list. It means the number in the 1th index should be the first element in the list, and number in the 10th position should be the second element in the list, and it should keep going. For example, if you got number 807, we need to have a list something like this: 7 to 0 to 8. So what we require is we need the last digit of the number every time. So let's take the number, do the modulo division, and that will give the last digit, and insert that into the list. So let's start with 807, and modulo division of 10, we will get 7 and insert it into the list. Then change the number by floor division of 10. 807 floor division of 10 is 80. Then again do modulo division. 80 modulo division 10, we will get 0. Insert that into the list. Then do the floor division. 80 floor division 10 is 8. Then again do 8 modulo division of 10. We will get 8. Insert that into the list. Then do floor division of 8 by 10 equal to 0. We should stop when we reach 0. So when we reach 0, we have already constructed the list, and then we have to return the index of 7. So we have to return the node of 7, that is going to be the head node in the list. Let's have a head as none first, and current node also none. Let's have one previous node also, because every time we create a new node we have to update the previous node. And we will have a while loop until the num becomes 0. Let's do modulo division to get the current value. And create a new node with the value. If head is none, let's assign the current node to head if head is none. If previous node is already there, let's update previous nodes next to the current node. And let's set current node as a previous node for subsequent cycles. And finally return the head. Hope the implementation is correct. Let's execute the code and see whether it returns what we need. It says memory limit exceeded. What did we do? Yes, we take the value, but we forgot to update the num. We will do floor division of num by 10 to take the last digit out from that num. Okay, 1 and 3 are successful and case 2 is false. The reason is case 2, the input are 0 and 0 and it is expecting output of with one node with 0, but we are returning a null. We'll see why we do like that. When you have 0 as the input, what will happen? Because it is already 0 and we are simply returning none. We will not even enter into the while loop because num is already 0 and we are going to return head, and head is nothing but initialized to none. This should not be the case. In this case, they are expecting a node with value 0. So we will have a corner case handling here. Instead of simply returning head, if not head, if head is none, let's create a head node. So if head is so for every other value the while loop will execute and head will not be none. If the number is 0, while loop will not get executed and at this place head will be none, and when head is none we are creating a 0th node and assign that to head. So when we return the head finally, it is going to have a one node with value 0. Let's run this one. We are getting an error. List node is not subscriptable. We have syntax error probably. Okay, this we should have called it because it is an object initialization, but we have subscripted it for some. Yes, we got all 3 cases successful. Let's try to submit this code. Okay, good. It is an accepted solution and all the cases, all the 1516 cases are passed. And we are not so bad. We are at the top quadrant. Our solution executed in 3 millisecond runtime. But still there is a better opportunity. We can even run that much faster. We will see that in the next video. And please subscribe not to miss that. Thank you for watching.